All right, so now let's again look at a couple of linear algebra problem. This is kind of like a summary of our semester. See, we have a vector v1, v2, and b, and it asks us for what value of h in b in the plane spanned by those two given vectors. Okay, so in other words, the span of v1 and v2, it is the span of v1, v2 stands for all the linear combinations, of vector v1 and v2, right? So, of course, if you think about it into the three-dimensionals, is going to be the plane. So the question asks us for which value this is going to be in that plane. So in other words, we're looking for, is it possible that this B can be represented as a linear combination of V1 and V2? Okay, so so in other words, we are looking for, okay, there exists a x1 and x2 such that this is 2. Okay, so this is a vector equation, and we can, of course, 1, 6, negative 4, negative 2, negative 1, 3, right? We're looking for, which value of h will make this matrix equation consistent. Okay, so it's equivalent. We're looking for the corresponding augmented matrix, right? Okay, so that's the augmented matrix, and then we're starting to work on that and trying to figure out its echelon form. So as you can see, if we let row 3 plus 4 times row 1 to become the new row 3, clearly you will see it will be 1, negative 2, 1, 6, negative 1, 2, and then what do we have? We're going to have 0 here, right? So 3 plus negative 8, it becomes negative 5, okay? And then, of course, it's h plus 4, right? So it's h plus 4, okay. And then we can keep going to let row 2 minus 6 times row 1 to becomes new row 2, and so that will give us 1, negative 1, 1, negative 2, 1, 0, right? So this minus 6 times this becoming to plus 12, so it's 11. And so 2 minus 6 would become minus 4. We have 0, negative 5, h plus 4. Okay. And of course, we can do what? What we can do is we can use the row 3, right? Plus 5 over 11 of row 2, let it become into the row 3, because we want to get rid of this. That is so this part is gonna come into 0, right? So it's 11. 5 over 11 times 11 is 5, adding them together is 0. So this piece is going to be coming into h plus 4, right? Plus 5 over 11 times -4. Okay, so that's what we have. So it turns out that if we want this matrix equation to be consistent, keep in mind I only have two variables here, right? And then I also have, I need to make sure that I only have the two pivots, and then I'm all good to go. To accomplish that, that means that I need to make sure that this last entry here, it must be 0. Otherwise your system is going to be inconsistent, because you're going to have 0, 0. This part become, something non-zero. So you have h plus 4 plus 5 over 11 times -4 must become into 0. That is, h plus 4 minus 20 over 11 equals 0. So h plus, 44 over 11 minus 20 over 11 equals 0. And then easily you can figure out that h equals -24 over 11. Okay, so this will make this entry to become 0, and then it will make the system consistent. Hence, meaning that there exists x1 and x2 such that B is a linear combination of V1 and V2, and then B for sure is going to be in the plane spanned by those two given vectors. Okay, so that's the first part. Now the second problem, it's simpler. So we have a linear system. Figure out its echelon form, not to the reduced, and for the augmented matrix, and then based on the echelon form result, is this system consistent or not? This is basically it's a repeated part of the previous example. So 1, -2, 1, -2, 0, -1, 3, 1, -2, -2, -3, 6, right? So this is the augmented matrix. So this part is 0, great. Let's have row 3 plus 2 times row 1 becomes the new row 3. So we have 0, -1, 3, 1. We have 0. This kind of becomes into -6, right? This is -1. This is going to become 2. Okay. And then we can try to get rid of this. So we can use row 3 minus 6 row 2 becomes new row 3. So it's 1, -1, -2, 1, -2, 0, -1, 3, 1, 0, 0. So this is -1 minus 18 become -19. So 2 minus 6 become -4. Okay, so you can see that this is the echelon form here, and it turns out that we have a pivot. Excuse me. We have a pivot in each row. So as you can see that this system actually it is consistent. Okay, so yes, it is consistent. Okay, so hope you enjoyed this, and I'll be back soon.